Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to our NPTEL online certification courses on engineering drawing and computer graphics. We are in module number 2, lecture number 15 on conic sections. And in today's class, we will learn more about how to construct parabola. So, a parabola will be constructed by taking a parallel section to the slant and passing through this section. That gives us parabola. There are mainly three methods available for constructing parabola. One is using focus directrix method, second one is rectangle method, and the third one is tangent method. To construct it through focus directrix method, let us recap how to construct this. A directrix is the one which is having infinite eccentricity. Let us look at briefly. If there is a focus, a circle with increase in eccentricity turns out to be an ellipse. Further increase in this eccentricity from the directrix, it becomes a parabola for which eccentricity is equal to 1. So, this is the parabola for which eccentricity is 1. That means, pick any point on parabola, focus to point and directrix to that point makes equal ratio. In this case, this one and this one are one and the same. Usually we note it by focus, maybe a point V and this point C. On CC axis, CV and VF are one and the same for parabola. Further increase in eccentricity, one will be going to get a hyperbola. Infinite eccentricity is the vertical line or this straight line. We have already learned eccentricity is distance of point from focus to distance from directrix. Now, using focus directrix method, the first one, focus directrix method, we will construct a parabola. If the distance of focus, let us begin with an example, focus from the directrix is given and eccentricity is given. For parabola, eccentricity always be 1, whether it is given or not. Let us construct a parabola. For example, a parabola has an eccentricity 1 and distance of focus from the directrix, let us take 60 mm in this case. So, using directrix focus method, we are going to construct this parabola. Let us call this point is C and this is C prime, and focus in our definition F. By eccentricity, we will be in a position to locate V, where VF is equal to CV. For this purpose, what we do is First draw AB line as directrix, then a perpendicular line CC dash. The distance from focus from the directrix is known. So, locate this point V by knowing C and F. Once this CV VF is known, we are going to construct the rest of the parabola. Okay. Let us name this is C, C prime, V point, A, B point as directrix. First draw directrix AB on axis CC prime. So, parallelly let us construct it on our graph sheet. AB we have to draw first. Directrix is a vertical line, name it A somewhere B, draw something axis CC prime which is horizontal line, perhaps let us draw a very long line, name it CC prime, this is axis and this is directrix. Once it is done, mark F on CC prime such that CF is equal to 60 mm. Let us go on to our sheet. Mark F on CC such that CF is equal to 60 mm means here let us go ahead mark 60 mm. So, this is the point where we have focus. Now, mark V at midpoint of CF. Because eccentricity is 1, we are going to mark at midpoint which is at 30 mm. So, after that at V draw a perpendicular VB is equal to VF, a perpendicular VB is equal to VF, V B is equal to VF means this is VF, here we have to draw a perpendicular in that direction. Whatever the VF distance, here locate B. That means, now use our compass, whatever VF distance on our graph sheet, we mark it here on both sides. Join these points. So, this point is our B. B prime, let us call it. So, VB is equal to VF and then join C and B. So, C and B we have to join. So, on this is the way we have to join something like that. So, CB, let us join it. So, this point now we have to mark few points 1, 2, 3, 4, 5 on VC dash. So, V is this, C dash is that, mark something like 1, 2, 3 and 4 points. These are arbitrary points. So, let us pick somewhere at equidivision 1, 2, focus 5, 6 and 7 points, and there we have to draw perpendiculars. So, there we have to draw perpendiculars to them onto CB to get 1 dash, 2 dash, 3 dash, 4 dash. So, here because these are grid points are coinciding and our parabola pass through F. So, thereafter F we draw these lines, here also we draw these lines, draw these vertical, and so on. The way how we have constructed B prime, B we join C and B prime also, join C and B prime. Now, we have to mark, once we drop these perpendiculars from points 1, 2, 3, 4, let us call 1, 2, 3, 4, 5, drawing perpendiculars onto CB to get 1 prime, 2 prime, 1 prime, 2 prime, 3 prime, 4 prime. Same thing on this side also we will get. With F as center, let us look at sixth one. With F as center and radius 1, 1 dash. So, let us erase this, we are already done 1, 2, 3 points, and this one we named it as C, C dash, and this one as A and this one as B, and this is focus and this is V. Now, with F as center, that means this point we have to take, and radius 1, 1 dash. So, 1 is this, 1 dash is somewhere is joining CB line, somewhere if it is passing in that way, we have identified something like B point. So, 1 to 1 dash where it is going to intersect, that point on B curve, from B here we have located B. Okay. 1 we have extended, so that 1 dash we got. So, whatever 1 to 1 dash length, use that length from focus as center with F as center and radius 1, 1 dash, make an arc which intersect this curve. So, let us look at drawing sheet. 1, 1 dash, pick that length, this is the one. From focus we have to construct it, our focus is this, on to 1 intersect it, this is the point. Similarly, 2 to 2 dash, with focus center intersect it. 3 dash thing is going to intersect here itself. 4 to 4 dash, let us name this one, this is f dash and this is 3 dash and this is 4 dash. So, 3 to 3 dash, let us measure that. This is from F intersect this curve. Similarly, F 4 to 4 dash, use F intersect there. So, if we are having those points, join them. One can construct even at this point. Let us construct one more point here on BC. Here let us construct one more point. Here also we can really construct another one. However, this curve passed through V, so it has to go in this direction. That means, any middle points we can always construct it to improve the accuracy. So, measure this one all the way to this one, so that from F, if I am going to intersect, where it is going to intersect. So, if these points we are going to join, in that way it goes. Similarly, if we are constructing on the bottom side, this is one distance from focus intersect 1. Similarly, from this point construct focus as center. Similarly, from this point to all the way perpendicular to B prime line, but focus as center. Similarly, from this point focus with focus intersect it, and so on. So, we have these intersection points somewhere there, there, there and there, join a freehand curve. It goes in that direction, and this is the way we construct a parabola. If we are looking at this, pick any point on the curve. Let us pick first point, this one, point P. Let us pick this horizontal distance. Let us call this one D. FP by PD always be 1 by eccentricity definition. Now, we will go on to construct a second method, which is based on rectangle method for parabola construction. In this rectangle method, which we have learned for ellipse, similar strategy we will use. Let us look at that. A parabola has to be constructed with a rectangle size of 140 mm by 100 mm. So, first of all construct a rectangle point A, point B, something named D, maybe E and F. So, this is 140 mm and this is 100 mm. Now, what we have to do is, this point is C. Now, the major length A to B, which is 140 mm, because it is a rectangle length what we are trying to do, divide into equal number of points. So, C 1, 2,